Hello friends, welcome to Joy of Life. So today before the video I would like to thank you all for all your support and love for the channel. The channel has reached its first milestone mark of 100 subscribers. It was really great to have it under 3 months to have 100 subscribers. I personally think that is one of the biggest achievement for me to get so much of love and support from you all. So keep supporting me. I'll also try to meet your expectation and come up with different kind of technical and non-technical videos down the line. So today we are also going to look at a medium level problem from Leetcode. The problem number is 695. The name of the problem is max area of island. So given a non-empty 2D grid of zeros and ones, an island is a group of ones representing land. So we are given with a 2D array wherein we have zeros and ones. So 0 represents water and 1 represents the land. Connected 4 directions, horizontal and vertical. So we can um, uh, connect them horizontally and vertically and horizontally both. And also keep in mind that we are not supposed to connect it diagonally. So this is the wrong way. We can only expand the 4 sides, but not the squares, not the diagonals. So these are not allowed. So only these are the right ones. Okay. So what are we supposed to do? Find the maximum area of island. Maximum area of island in the given 2D array. If there is no island, the maximum is 0. And also they say that you may assume all 4 edges of the grid are surrounded by water. So you can assume these are water. So if a edge starts with a 1, do consider it to be island. So before we jump into more details, first let's look at some of the example and understand in the more details. So here we have a island. So let's figure out the islands over here. So here I see one island. Here is another island. Here also I see island. Just mind it, they are connected diagonally, but don't consider to be one big island. They are two separate islands over here. So we are only supposed to get connected horizontally or vertically. We are not supposed to connect diagonally. So no more one. So here I see an island of size 6. Here I see one of 5. Here there is another 5. Here I have a 4. Here also I have a 4. Here I have a 1. So the biggest being 6, and 6 is our answer. And also they have pointed out that your answer is not 11. Do not connect these two islands. They are separate islands. So consider them to be separate. So do give it a try yourself to come up with the solution. As a hint, what I could say is there is a problem, similar problem that was done by me previously. The problem number, as I recall, is 200, I guess, and that would give you a lot of hint on how to solve. So do give it a try before you look at the solution, and let's move over to the board. Let's get the example from this problem to the board and try to solve it. So I have copied the input array from the Leetcode to the board, and for the sake of simplicity and for visualization purpose, what I did is I have marked 0 with a different color and 1 with a different color, and also given a border around them so that you can visualize it pretty easily. And what we need to do is we have to figure out the largest island. So if you remember, some time back, we, just as I mentioned, we did a similar problem from Leetcode where we were given with a similar grid with ones and zeros, and where we needed to count the number of islands. So we are going to do something very similar over here in order to come up with the solution. So we are going to use the similar technique that we have used previously in order to solve the problem. So what I'll do is I'll create a Boolean array of same size, and we will call it visited array. And we are going to use that array in order to track the island that we have explored and the unexplored ones. So I've created a Boolean array of the same size. And as you know that in a Boolean array, when you create the array, what happens is everything is initially set to false. So consider that we have everything false in the array at the moment. Okay. So what we are going to do now, we will start iterating over the two-dimensional grid. So we'll start iterating over the input array. And so what I'll do is we will iterate over the array. So let's say we are doing a for loop the way we do with uh, let's say input.length. And what we are going to do is we are going to go in a row column order traversal, the usual, the general way we do, right? And do keep in mind that every cell every cell in the input is mapped to the cell in visited as well. So it tells me whether the cell has been visited or not. So what I'll start doing is I will start checking that whenever I find a 1, so what I am looking for is a 1. So I'll start the traversal. So we will always check for input ij. So if my input ij is 1 and at the same time, so when it is 1, it means it is an island that my pointer is or my ij is currently pointing to, and it has not been previously visited. That means that my visited, in the visited I'll check at the same ij index, and it is not visited basically. What we'll do is we will call a function to explore this island, explore island. Let's say we'll call explore island, and what explore island will do, so let's say the explore island is called with 03 initially, right? So what it will do is it will first go and mark this 03 corresponding cell as true. Okay, and then it will try to explore all its neighbors. So when I say neighbors, there are 4 neighbors in our case. So one is north, this one is east, then south. Let me create some space for you here, and then west. So it's a recursive function. So when it will, what does it mean? It is exploring. So it means it will call the same explore island function again if it sees any of these values is a 1, or is it, or if it is a legitimate cell. So when I start with say 03, so when I try to look at my top, what happens is I start looking at -1 3. So this is not a legitimate index, right? It is out of bounds. So I'll exclude my north. Then what I'll try, so north is excluded. I will try to look for my east. So east means the index that we are referring to is a 04. So 04 we see it's a 0. So there is no point. So what I'll do, I'll try to look below. So below means 1 3. 1 3 we see it's 0. So there is no chance. And then we'll try to check our west, uh, which is 02, and it's also 0. So what happens is it returns, the function returns the size that it has explored. So how many cell it has changed in its course? It has changed just one cell, and that is this cell over here. So it is going to return a 1 to me. So we are going to keep a track of the max. Is max is initialized to 0, and at every point I am going to check my max. And how do I check? So let me remove this. So what I'll do is I'll call this function, and what this function will do, it will give me the maximum area covered by it, and I am going to check this with my current max and take a max and store it to max. So my current max is 0, and what I get is a 1. So this will get updated with 1. So this moves on. So it goes to the next index, next index, next index, and finally next index and next index. So this is 0, 1, 2, 3, 4, 5, 6, 7. So it will be called with say 07. So let me clean this part. And okay, so what happens is it is called with 07 now, right? So what we'll do is, first thing first, we'll go and update in the table that we have stepped on an island again, and we will mark it as visited. So having said that, we will 1, 2, 3, 4. So we are going to come here and mark it as true. So remember, it was previously all false. So what this function will try now, so it knows that it has explored that cell. Now it is going to call its north. So north, when it tries to call, it calls with -17. So it's an invalid index. So it will not go that side. Then it will call its east. East is 08. So it will call 08. And 08 it sees a 0, so it will not continue there. And then it will call its south, which is 17. And in south, what we see is a 1 over here. What we see is a 1. So as it is called with 17, it will be marked true. And this 17 will now try to explore its neighbors. It's a recursive function, right? So it will first look for what? 07. We look the north first. But we see that this is already being marked as visited. We have a true here, so we will not proceed that way. We will try its east. So we'll try with 18. So at 18, let me make some space for myself. Okay, let me make it a little smaller. Okay, so at 18, what happens is it sees a 1. So it marks 18, and 18 calls spawns another function, right? What that function does is, first it goes ahead and checks the north, means 08. So 08, we see a value of 0 over here. So it does not continue. It goes and checks its east. And east means we check for 19. And 19 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is a 1. So 19 is a 1. So it marks this to be true. And it calls 19. So 19 again checks its north, which is 09. Which is a 0. 09 is this cell, which is a 0. So it goes east, that is 110, which is also a 0. Then it looks down. When it looks down, what it gets a 29. 29 is also a 0, this cell. And then it tries for the west, which is a 18. And what it sees is 8 is a 1, but the it has already been visited as per my Boolean array. So it will return 1 from here to this guy. So he receives a 1 here from him, right? So this part exploration is done. So this part's north and east was done. So we'll go to the south now. In south, what we see is we get a 2 and a 8. So 2 and a 8 is a 0. So no point going there. And it tries for 1 and a 7. In the west, it gets a 1, but it sees that it's already visited. So it won't go there. So it will return. So he has already received a 1. So he will return 1 plus 1. He will return a 2 to him. So here also we are done with north and east. West was remaining. So west means 2 and 7. So 2 and 7 means this cell over here. So 2 and 7 sees that it's a 0. So what it does is it calls the west, and it tries for 1 and a 6. And 1 and a 6 is also a 0. So he returns, he gets a 2 from his caller function over here, right? So he returns 2 plus 1, 3 to him, right? So here we were done with the north, east, south, and the only part remaining was a west. So in the west, what it gets is a 0 and a 6. 0 and a 6 is a 0. So it has received a 3 already, and he adds 1 and return. So what he returns back is a 4 to the actual function. So I receive a 4 over here, and my previous max was a 1. So I update my max and change it to 4. So this is the approach how this algorithm works. So I have just shown you for this island. So the similar thing will continue for the entire array. And at the end, whenever we visit a cell over here, what will happen is these cell will start getting marked as true, so that they are not visited or they are not considered again in the program. So when you are done with this entire array, what will happen is you will have a Boolean array, something which looks something like this, and which will signify that we have traversed all the islands, and we have stepped over all the islands, and I have collected all the results from each of the islands, and I have every time I got a result, I have updated my max, and I am now ready to say which is the best max. So as you see, this guy has returned a 4 to me. This guy will has returned previously a 1 to me. Similarly, in future, what will happen is if we continue with the same process that I have shown over here, is this guy will return me a 4 again. This guy will return me a 5 again. This guy will return me a 6, and this guy will return me a 5. But we will, since we are keeping only the max, we will end up with the result which is 6. So this is the similar algorithm that we have previously also done in this problem. So we kept a discovered map, and we just call the discovered function, and every time. So here what was our intention? It was to count the number of islands, but this time we needed the biggest of all the islands. So we will quickly see in the code how the solution looks, and we will check our result. We will start with the solution, and we'll write the code as we have discussed. The main thing that is required is to keep a track of the max, which is initialized to 0, and at the end we'll be returning the max. So this is my final output to the problem. So what we'll do is we'll create a Boolean array, and let's call it is visited or not, and we will create the array of the same size as the grid. So we'll call this grid.length, and so it's a m into n matrix, right? Yeah, they are not of the same size, so grid 0 dot length. So our array is created now, and by default it will be initialized with all zeros. And here what I'll do is I'll start with int I equals to 0. This is just a simple grid or a two-dimensional array traversal logic, nothing special over here. So we need two variables to iterate over the row and columns. So I'm just doing the same thing. So yeah, so we are done with the traversal part, and now what we are going to do, so basically what we'll do is, if first thing is that we need to check that the element that we are standing on is a 1 or not. If grid, it's an integer array, so grid ij, if grid ij is 1 and not of visited ij, so it has to be true as well. In that case only we are going to call the explore island function, right? So here we'll call the explore island function, and also whatever I get, I need to check with my max and update my max accordingly. So I'll do a math.max along with the max, and let me create the function. So this function will let's see what all we need. So this function has to return an integer that is the size of the island, right? And let's call this function, okay, we have named it explore island. Okay, so what all I need over here, I need the grid over here, and I need the Boolean array as well. So whatever is visited or not, we need to check at every point of time, right? And also we need to know the row and the column. So I'll say int I and j. right? For the sake of simplicity, I'm just keeping it ij. You can name it row column or whatever you want. Yeah, so this is my base logic over here. So what I'm going to do right now is, first is there are several conditions that we need to put as a base condition where this loop should terminate and should not proceed any further. So first is I, if I is greater than grid's length, right? If I has exceeded the grid's length, or j has exceeded greater than or equal to, because it's a zero based index, so grid I'll say grid 0 dot length, or you can put grid I dot length as well. So in those cases I can say that I can return a 0. So this is my row level check that I'm, if I less than 0. Of course you can merge them into single condition, but I am keeping it separate over here for the sake of readability, you can say. If j less than 0, in this case also we are going to return a 0. So here I have checked uh, for the max index. Here I have checked for the min index. I'm just separately having them into two separate condition. Definitely they can be merged. Okay, so these are my two index based exit criteria from the recursion. Other than that, what is the next most important exit criteria? So if I see that visited ij is true, that's another condition where I need to return and say that I am not going any further. So this cell has been previously explored. This step is this is not the first time somebody has come to this cell. So this has already been explored. And what else? So of course I am telling you again, these condition can be merged, but I am not doing it just for the readability purpose, so that it's become easier for you to understand. The other condition is, if grid ij is 0 also, then also we can return 0. So these are my four exit criteria from the recursion. And what is next? The next is, these are all my exit criteria that has been done. So that means I am standing on a grid which is a 1 and which has not been visited. So my first work would be to mark that grid as visited. So I am just going to put visited ij equals to true. And what I am going to do is I am going to return a 1 now. So if you remember, I am going to return a 1. So every step, if you remember, we have returned here I have returned a 1, here I have returned a 1, here I have returned a 1, here also I have returned a 1. But we also added. So what does this return type signifies? So this return type basically signifies that I am contributing 1 to the answer plus all my four recursions, right? So we are calling branching out four recursion from this stage, right? At every stage we are branching out four recursions. So let's get that done. So what are those four recursions? So explore island. So we are going to call explore island with grid and visited, no change on them. So standing at the current cell, we have four options. First is north. North means that I is decremented, j remains unchanged. Plus, so just to tell you again, I am just decrementing I. So if my current row value is 20, I have to, when I look my north, it will be 10. Just decrement I. So explore island. Again, I call grid and visited. Now what I am going is a east. So east means I remains the same, the row is same, so j is just incremented, right? So east is done. Now my next is south. So again, grid visited. South means my row will increment, but my column will remain the same. So 20 means the row below me, which is a 30. Similarly, for west, we'll do the same thing. explore island, grid, visited. So here I will remain the same, j will be decremented. So if I am at say at an index of 3 1, so my previous index is a 3 0. So I is unchanged and this one is just decremented. So yeah, that's it. This is the entire code for you. This is the algorithm and the code for you. So let's run and check. Okay, I did not pass them anything. I don't know when I'll be able to run a program at the first time without any mistake. Let's wait for that day. Typos and mistakes will kill me someday. Yeah, so it has been accepted, though the mistakes were not that impactful. Pretty simple ones. Okay, so it has been accepted, and you can see that it is better than 99% of the submissions in terms of performance, and in terms of memory usage also. It's 95.9779% faster than the other submissions. So just to tell you one thing over here, the algorithm that sorry the algorithm that we have discussed over here, this is a very common algorithm. In my last video, I have not talked about it, but this algorithm is called flood fill algorithm. Okay, so yeah, that is all. Do let me know what do you think about the solution. Do share with your friends. Do subscribe it if you haven't done so. And once again, thanks a lot. Thanks a lot for all your support and love for the channel. It was a great feeling to have 100 subscribers. So thank you once again. Have a great day. See you soon again. Bye bye.